Hello students, in previous class we discussed activity. So what is that activity? When light travel from rarer to denser medium, then what happen? When light travel from rarer to denser medium, then the refracted ray move towards the normal and the angle of refraction is less than angle of incidence. Today we are discussing one more activity. What is that activity? What happens when light ray travels from a denser medium to rarer medium? To perform this activity, we need one metal disc, protractor, and transparent vessel, water, straw. First, take a metal disc and use a protractor and mark the angles along its edge as shown in the figure. First, take a metal disc and use a protractor and mark the angles along its edge as shown in the figure 5th A. Arrange two straws at the center of the disc in such a way that they can be rotated freely about the center of the disc. So in figure 5b, we immerse straw. In that red colored lines we can observe two red colored lines. So that are nothing but two straws. Okay, we arrange two straws at the center of the disc in such a way that they can be rotated freely about the center of the disc. Adjust one of the straw to make an angle 10 degrees. Immerse half of the disc vertically into the water filled in a transparent vessel. While dipping, verify that the straw at 10 degrees is inside the water. So we adjusted one of the straw to make an angle 10 degrees and we immersed half of the disc vertically into the water filled in a transparent vessel. While dipping, verify that the straw at 10 degrees is inside the water. From the top of the vessel, try to view the straw which is inside the water as shown in the figure 5th B. Then adjust the other straw which is outside the water until both the straws appears to be in a single straight line. Here we adjusted two straws. One straw is making angle 10 degrees. So that immerse half of the disc vertically into the water filled in a transparent vessel. While dipping, verify that the straw is at 10 degrees inside the water. So we are immersed metal disc into the water, no? So when we are immersing metal disc into the water, that the straw which is at 10 degrees, that should be inside the water. Next, from the top of the vessel, try to view the straw which is inside the water as shown in the figure 5th B. Then adjust the other straw which is outside the water until both the straws appears to be in a single straight line. So one straw is inside the water. Okay, from the top of the view, from the top of the vessel, we are trying to see the inside straw. Okay, next, then adjust the other straw which is outside the water until the both straws appears to be in a single straight line. Means here one straw is inside the water, one straw is outside the water. So by seeing the inside straw, the straw which is at outside, that should be adjusted. When we are adjusting the straw which is at outside, we should see that the inside straw and outside straw will be in the same straight line. Then take the disc out of the water and observe the two straws on it. Take out the disc. Okay, then take the disc outside of the water and observe the two straws on each. So you will find that they are not in a single straight line. So next, take the disc which is outside. Take the disc outside of the water. Okay, we should take out the metal disc outside and observe the two straws on each. So then we can observe that they are not in a single straight line. Okay, the two straws are not in straight line. Why do the stars appears to be in a straight line when we view them from the top? So when we are seeing from the top, why the two stars appears to be in a single straight line? Next, measure the angle between the normal and second star and draw the table 2 again in your notebook and note the values. Do the same for various angles, means here we perform this experiment from 10 degrees, no, next perform the same experiment from 20 degrees, 30 degrees, by keeping the star at 20 degrees, 30 degrees, 40 degrees, 50 degrees, like that. Okay, and then observe the outside star. Okay, arrange the outside star that should be in the same line with the first star. Okay, and next take out the metal disc and observe the angle of refraction. Do the same for various angles. Find the corresponding angles of refraction and note them in the table drawn. So here we are performing this experiment from 10 degrees, 20 degrees, 30 degrees, 40 degrees, and we measure the angle of refraction. This angle of incidence and angle of refraction value we should note down in the table. Okay, like previous activity. In previous activity, the drawn one table, no, we measure the angle of incidence and angle of refraction value, no, like that here also we should do, and use the data in the table too, and find the refractive index of a water. So do not take up this activity for angle of incidence greater than 48 degrees. Okay, so don't perform this activity more than 48 degrees. Okay, you will learn the reason for this in the following sections. So you will observe that in the above activity, R is greater than I in all cases. That means when light travel from water to air, means denser to rarer media, then what happened? Angle of refraction will be more than the angle of incidence. So from the above angle of incidence and the angle of refraction value, we can find out angle R is greater than I in all cases. That means when light travel from denser to rarer, means from water to air, then what happened? Refracted ray move away from the normal and angle of refraction will be more than the angle of incidence. So from this activity we can generalize that when the light ray travels from denser to rarer, it bends away from the normal and R is greater than I. So already we discussed in previous topic also. What is that? Light travel from denser to rarer media. Okay, V1 and V2. That time V2 is greater than V1. Okay, in that also we discussed. Hello students, in previous class we discussed about Snell's law and what happened to the light when it is travel from denser to rarer medium. In this class we are discussing about total internal reflection. So what is the meaning of total internal reflection? Is there any chance to angle of refraction is equal to 90 degrees? When does this happen? Let us find out. Yes, when angle of incidence is equal to critical angle, then the angle of refraction is equal to 90 degrees. Okay, so when the angle of incidence is equal to critical angle, then the angle of refraction is equal to 90 degrees. So what is the relation between this angle of refractions to be equal to 90 degrees and the critical angle and total internal reflection? We will discuss clearly in this chapter. Okay, so first, what is the meaning of critical angle? Now we will discuss. Critical angle is nothing but the angle of incidence at which the light ray travel from denser to rarer medium grazes along the interface is called as critical angle of that surface. So here critical angle is nothing but when the light is travel from denser medium to rarer medium Then at certain angle of incidence the refracted ray is travel through the surface which is separating the two mediums. Then the angle of incidence will be there, no? So that angle of incidence is called as critical angle. And what is the meaning of total internal reflection? Total internal reflection is nothing but when the light travel from denser medium to rarer medium, if the angle of incidence is greater than the critical angle, then the refracted ray entering back into the same medium, that concept is called as total internal reflection. So we will discuss about this critical angle and total internal reflection with one activity. By performing this activity we can understood about critical angle and total internal reflection clearly. So now we are discussing about total internal reflection and critical angle. So now to perform this activity we need some materials. What are that materials means? In previous classes we performed some experiments, no? What is that? Use the same materials as used in lab activity 1. Here lab activity 1 is nothing but light travel from rarer to denser media, then the refracted ray is moved towards the normal. That activity there, no? In that activity we used some material, no? We are used some material, no? That materials only we are using, okay? Use the same materials used in lab activity 1, okay? What are that materials? A plank, white chart, protractor, scale, small black painted plank, semicircular glass disc, and pencil and laser light. Okay. And first, okay, take a wooden plank which is covered with white chart. Now draw two perpendicular lines that are passing through the middle of the paper as shown in the figure 4a. So the two lines are intersect at one point, no? Let the point of intersection is O. Mark one line as NN which is normal to the another line, which is normal to another line, and another line we should mark as MM. So here we drawn from the middle of the paper two lines, no? One vertical line, one horizontal line. So mark NN as NN for vertical line and mark MM for horizontal line. Here MM represent the line drawn along the interface of two media, NN represent the normal. Here NN is represent the normal and MM is nothing but that is separating the two media. So place a semicircular glass disc in such a way that its diameter coincide with the interface line MM and its center is coincide with the point O as we have done in the lab activity. So now we should place a semicircular glass disc in such a way that its diameter is coincide with interface line MM and its center is coincide with the point O. Okay. Now send light from the curved side of the semicircular glass disc. This means that we are making the light travel from denser medium to rarer medium. Okay. So remember this point carefully. In lab activity 1, that in that lab activity we send light from rarer to denser medium, means semicircular glass disc is there, no? That we kept upside of the MM. Okay, and we send the laser light from MM downside, means air to glass slab we send, but here we should place the glass slab MM downside. Okay, we should place the glass slab MM downside. Okay, upside rarer media, means air will be there. Okay, so in that activity we kept glass slab MM upside, no? But now we should place the glass slab MM downside. Okay, so now send the laser light from curved side of the semicircular glass disc, means we kept the glass disc MM downside. Okay, this means that we are making the light to travel from denser medium to rarer medium, means here two mediums will be there. Okay, line is separating the two medium, means downside we kept semicircular glass disc. Okay, and its diameter is coincide with the interface line and its center coincide with the point O. Here glass disc is denser medium, and from upside what is there? Air is there. Air is rarer medium, means we are making the light to travel from denser medium to rarer medium. Okay, start with angle of incidence I equal to 0 degrees, means with the help of protractor we make the angles at right side of the NN and left side of the NN, no. So in that activity we did know, here also we should make the angle same like that only with the help of protractor. Start with angle of incidence I equal to 0 degrees along the normal and look for the refracted ray on the other side of the disc. Okay, means now we should send the laser light from denser medium, means from curved path of a semicircular glass disc. Okay, start with angle of incidence I equal to 0 degrees. Okay, means along the normal. Okay, and look for the refracted ray on the other side of the disc. So where do you find the refracted ray? Does it deviate from its path when it enters the rarer medium? No. Okay, you might have observed that it does not deviate. Okay, so it follows the same path. Send the laser light along the angle of incidence 5 degrees, 10 degrees, 15 degrees, etc. and measure the angle of refraction and tabulate the results in table 3 as shown in below and note the values of I and R in the table. Okay, now send the laser light along the angle of incidence of 5 degrees, 10 degrees and 15 degrees and then measure the angle of refraction, means first we are send the light from 0 degree, no, now send the light from 5 degrees. Okay, and then what happened when we are sending the light from 5 degrees, the light travel through the glass slab and fall at the point 0 and entering into the rarer media. Okay, that time how much the angle of refraction we should measure. Okay, after that send the laser light from 10 degrees and measure the angle of refraction. After that send the laser light from 15 degrees and measure the angle of refraction. So draw the table. Okay, and measure the angle of incidence I value and angle of refraction R value. Okay, at what angle of incidence do you notice that the refracted ray grazed the interface separating the two media? You will observe that at a certain angle of incidence the refracted ray does not come out but grazes the interface separating the air and glass. Measure the angle of incidence for this situation. This angle of incidence is known as critical angle. Means at certain angle of incidence the refracted ray is there. So at certain angle of incidence means when we are sending the light from denser medium to rarer medium, that time the refracted ray is there, no, that is travel through the surface which is separating the two mediums, means at certain angle of incidence the refracted ray is there, no, that is travel through the surface which is separating through the two mediums. Okay, na? So that angle of incidence is known as critical angle. So in this figure 7, okay, figure 7 once you see, okay, so in that figure we can observe, okay, red colored line is okay. In this figure 7 we can observe one dotted line in vertical direction and it is normal, and we can observe one horizontal line downside blue colored portion is there, means that is denser medium. Horizontal line upside what is there? White colored portion is there, that is rarer medium. Okay, so at certain here red colored line in denser medium we can observe one red colored line. Okay, and that is nothing but angle of incidence. Okay, now so in blue colored portion we can observe one red colored line. At the same time on horizontal line which is separating the two mediums. Okay, there also we can observe one red colored line. So at certain angle of incidence, then the refracted rays travel through the surface which is separating two media. That angle of incidence is called as critical angle. The above results can be explained by using a Fermat principle. So let us consider that light travel from medium 1 with refractive index n1 to medium 2 with refractive index n2. See in figure 7. So it is already found that the angle of refraction is more than the angle of incidence when light travel from denser medium to rarer medium. So now we will the above results we can explain with the help of Fermat principle. So what is the Fermat principle? Will say when light travel from one medium to another medium, it is the ratio of sine of angle of incidence to sine of angle of refraction. So let us consider a light ray travel from medium 1 with refractive index n1 to medium 2 with refractive index n2. See in figure 7. It is already found that the angle of refraction is more than the angle of incidence. The angle of refraction is more than the angle of incidence when the light travel from denser medium to rarer medium. Okay, when the light travel from denser medium to rarer medium, then the angle of refraction is more than the angle of incidence. So for the angle of incidence I, let R be the angle of refraction. Okay, from Snell's law we can write like this: n1 sin I equal to n2 sin R. Okay, so we can write the Snell's law like this: n1 sin I equal to n2 sin R. So from this equation we can write like this: n1 by n2 equal to sin R by sin I. Okay, n1 by n2 equal to sin R by sin I. We know that n1 by n2 is greater than 1, so that the sin R by sin I is greater than 1. So we conclude that the angle of refraction is greater than the angle of incidence, so R is greater than I. Okay, so Snell's law n1 sin I is equals to n2 sin R we can write now. So from that we can write like this: n1 by n2 is equals to sin R by sin I. The angle of incidence at which the light ray traveling from denser to rarer medium grazes the interface is called critical angle for the denser medium. So what is the meaning of critical angle of a denser medium? At certain angle of incidence, when the light ray is traveling from denser medium to rarer medium, then the refracted ray is travel through the surface which is separating the two mediums. Okay, that angle of incidence is called as critical angle. So this critical angle is showed by C. Okay, let C is the critical angle, then R becomes 90. Okay, so I told you, no, at certain angle of incidence the refracted ray is travel through the surface which is separating the two mediums. Okay, so critical angle is showed by C. Okay, let C is the critical angle, then how much R? R becomes 90 degrees. Okay, R is angle of refraction, that becomes 90 degrees. So here Snell's law, from Snell's law we got n1 by n2 is equals to sin R by sin I. No, substitute that R value, R is equals to 90 degrees in the above equation. Then what will come? n1 by n2 equal to sin R by sin I. No, so then we should substitute R is equals to 90 degrees. n1 by n2 is equals to sin 90 degrees by sin I. In the place of I we should write C. Why? Because angle of incidence, that is critical angle. No, that's why we should write sin C. Then what will come? n1 by n2 equal to sin 90 equal to 1. No, so substitute that 1 in the place of sin 90. So 1 by sin C. So from this equation what will come? n1 by n2 equal to 1 by sin C. Okay, from this equation we can write like this. From which equation? n1 by n2 is equals to 1 by sin C is there. No, from that equation we can write like this: sin C equal to n2 by n1. Okay, from the above equation, sin c equal to n2 by n1 we can write. We know that n1 by n2, that is n12 is called as refractive index of a denser medium with respect to rarer medium. Okay, here we know that the n1 by n2, that is nothing but n12. Okay, that is called as refractive index of a denser medium with respect to rarer medium. So here sin c equal to n2 by n1 we can write, no? So here from the equation sin c equal to, we can write 1 by n12 also. Sin c equal to, we can write 1 by n12 also. So how we are written here 1 by n12 means n1 by n2 equal to n12, no? n1 by n2 is equal to n12, no? Then n2 by n1 equal to 1 by n12 we can written. So that's why in the place of n2 by n1 we are substituted n12. Okay, so sin c equal to 1 by n12. So okay, so what happened to light when the angle of incidence is greater than the critical angle? So what happened to the light when the angle of incidence is greater than the critical angle? When the angle of incidence is greater than the critical angle, the light ray gets reflected into the denser medium at the interface. Light never enters into the rarer medium. This phenomena is called as total internal reflection. So here I said critical angle. What is that critical angle? At certain angle of incidence, the refracted ray is 90 degrees. At certain angle of incidence, then the angle of refraction is 90 degrees. So that angle of incidence is called as critical angle. So now if the angle of incidence is greater than the critical angle, then what happened? So when the angle of incidence is greater than the critical angle, then light ray gets reflected back into the denser medium at the interface. Then the light never enter into the rarer medium. This phenomena is called as total internal reflection. So in figure 7, once you observe, in that we can observe one dotted line vertically, NN, the dotted line, that is called as normal, and we can observe one horizontal line. That horizontal line is called as that horizontal line is separating the two mediums. So in this horizontal line, downside blue colored portion is there, no, that is denser medium. Upside portion is called as rarer medium. In the denser medium, we can observe one red colored line, that is critical angle. So at the same time, we can observe red colored line on the horizontal line, which is separating the two medium. Means here at certain angle of incidence, refracted rays travel through the surface which is separating two mediums. So that angle is called as, critical angle. Okay. After this red line, we can observe black colored line, no? So that line, what is that line? Means here angle of incidence is greater than critical angle. We know that angle of incidence meaning. What is the meaning of angle of incidence? The angle between the normal and incident ray. So here we can imagine this red colored line also has a, in denser media red colored line is there, no? That we can also imagine has a incident ray only. Okay, but that time refracted rays travel to the surface which is separating two media. Okay, so that angle is called as critical angle. So after the red line, we can observe one black colored line, that also incident ray only. The angle between this black colored line and this normal is called as angle of incidence. Means in this situation, angle of incidence is more than the critical angle. So like this, if the angle of incidence is more than the critical angle, then what happen? If the angle of incidence is more than the critical angle, the reflector ray will be there, no? The refractor ray is not entering into the rarer media. Okay, it is entering into the denser medium only, that is entering into the same medium. Means here red colored line downside in the denser medium, one more black line we can observe, no? Okay, red colored line means horizontal line is there, no? Horizontal line. Okay, means NN. right side, red colored line is there, no, means angle of refraction is 90 degrees. Okay, that line downside blue colored portion is there, denser medium. In the denser medium one more ray is entering. Okay, means if the angle of incidence is more than the critical angle, the reflected ray will be there, no, that is entering into the same medium. This concept is called as total internal reflection.